Assalamualaikum warahmatullahi wabarakatuh. This is the video for our presentation of mini project for course foundation. So we from group number 7, and the members of the group, the first one is Julia N, Muhammad ZUHRY is me, Muhammad FARIS HAZWAN, and the NURUL SAPIQA ALIA BINTI SHAHRIL. Okay, and this video is presenting about the geotechnical design project of the foundation for the proposed 10-story building and the single-story management office in Kuala Perlis at Perlis. So the site location is near the area near the paddy field and require soil assessment due to its layer profile. So it has about 3 types of soil property. At near the top one is sandy silt, and then the mid stiff clay, and at the bottom which is hard sandy soil. Okay, so there are 2 project aims to develop safe and cost-effective foundation. For the management office, we use the MAP foundation. So it costs start at the 200 ringgit per square foot. And then for the 10-story building, we use the pile foundation. So the cost estimated around 400 ringgit per linear meter. Okay, the summary from the geotechnical design project of the report is stated that the construction will take about 24 months, including the site preparation, foundation, and building works. So for the management office size, is about 7 meter times 7 meter, and then for the 10-story building, which is 60 meter times 60 meter. This report recommend the foundation solution to ensure the stability of the structure.
My name is NURUL BINTI SHAHRIL. My matrix number is 211201776. Okay, this is the design for shallow foundation. Okay, first we need to calculate the area. The size of area is 7.5 times to 7.5, and then we calculate moment inertia, which is Ix and Iy. After we got the same answer because we use the same size, and then we calculate for total load shallow foundation, and the answer we got is 1700 kilonewton per meter. And then we need to calculate my. The formula of my is QEX, and then the EX formula is X minus 2B over 2. Then we calculate X prime. So the total of X prime is 3.75 meter. So EX is equal to 0. We calculate this, get value for my and mx. Okay, after that we need to calculate Q. The answer that we got for Q is 30.22 plus 1.35y. We need to calculate Q at every point, which is A, B, C, and D. For strip AC, we calculate average soil pressure then total soil pressure. After we got the value, we calculate average load. We calculate the average load and modify average soil pressure, and then we calculate average load divide by column load to get F. Then we calculate QA and QC. Okay, this is the shear moment diagram. Maximum moment, first 183.25 kilonewton meter, which is at positive point, and at the negative point is 681 kilonewton meter. For strike BD, we calculate same step like strip AC to get Q, but to get QB and QC. Okay, this is a shear and moment diagram for strip BD. To get a we calculate this to get a maximum moment, which is we got only one at negative point only. The answer is 973.53 kilonewton meter. Okay, this is the determined thickness of the mat. The value of BO is 1 plus T. U is 8.545 kilonewton. So we assume F prime C is 20.7 kilonewton per meter square. Fy is 413.7 kilonewton per meter. And lambda 1 is 1 because for normal high concrete, and beta is 1 for square column, and alpha is 20. Okay, for this calculation, we need to calculate VC first. Actually, VC we have 3 equations, so we need to use the 3 and then put the the answer of highest one to put at the H, and then next step we need to determine reinforcement. First we calculate for positive moment at AC. We need to calculate MU, which is the formula is M max divided by B1. So total is 48.87 kilonewton meter per meter. Second we calculate for maximum negative moment at BD. MU is equal to 260.67 kilonewton meter per meter. Okay, at the previous slide, AS that we got is 0.0425A. So A is equal to 0.0095 meter, and then we put at the AS formula, and then we got the answer is 404 millimeter square per meter. Okay, from table 2H25, AS we got is AS provided that we got is 982 millimeter square per meter. For negative reinforcement is AS we got 2312 millimeter square per meter, and then from table we got 2450, and then and then the last one is because of negative moment occur to meet board strip BD, so reinforcement should be provided MU, and then AS is equal to 2312 millimeter square per meter. Okay, this is the table. This is the diagram. At left and right is a top steel, while at the middle is the bottom steel. That's all from me. Thank you.
Hi, my name is Juliana LIDAM. Today I will present about the soil properties. First is for the shallow foundation. As we can see from the slide, the shallow foundation we use two borehole, which is borehole 1 and borehole 2. From the depth 1.5 meter to 9 meter, the soil is become city clay. Meanwhile, at the 10.95 meter, the soil is become glacial and harder. For the shallow foundation, the shear strength influence the coefficient impact the foundation sentiment rotation, and the moisture content also is important, as the higher moisture can be weakly soil and leading to excessive settlement. For the deep foundation, as we can see from the slide, we use 3 borehole, which is borehole 2, borehole 3, and borehole 4. From the borehole 2 to borehole 3, the depth at the 60.5 meter, the soil becomes stiff sandy sill, and the unit weight is 21.5 kilonewton per meter cube. At the 22.5 meter depth, the soil becomes stiff clay, and the unit weight is 23.5 kilonewton per meter cube. Meanwhile, at the 30.43 meter, the soil becomes harder sandy, and the unit weight of soil is 23 kilonewton per meter cube. From borehole 3 and borehole 4, the soil is become stiff sandy sill, and the unit weight is 21.5 kN per meter cube at the depth 60.5 meter. Meanwhile, at the depth 30.43, the unit weight is 23.0 kN per meter cube, and the soil it become harder sandy. Next, for the groundwater condition, first is the higher groundwater pressure, and the level can be increase the buoyancy and the uplift force on the foundation, and will be the give the decrease of the soil effect stress and shear strength, and the result in the seepage and pipe issue. Second one is for the shallow foundation, the higher groundwater can be cause the erosion of the foundation. For the deep foundation will be affect the soil strength, particularly the soil is oversaturated. For the third one is the groundwater seepage can be weaken the soil and affect barrier capacity, which may necessary the installation of the drainage system to manage water around the foundation. Next is for the load assumption for 10-story building and management office. First is the critical for the design a safe and structural and sound building. The second one is typical of the estimate based on the material using in construction such as reinforced concrete or steel. The third one is to ensure that the soil can support the building weight with typical pressure ranging from 100 to 400 kPa. The fourth one is to ensure that the stability and performance under expected condition. Next, for design code and standard, first is to assist the physical, mechanical, and geotechnical properties of the soil at the construction site. Second one is to conduct accurately, safely, and according to requires best practice, provide essential information for the design of the foundation and other civil engineering structure. Third one is a CPT is used to obtain a continuous profile of soil properties in the real time. It measures the resistance of soil to penetration, providing information on soil stratigraph density and shear strength. For the SPT test is used to assess the relative density of the granular soil and to obtain the estimate of the barrier capacity of the soil.
For this project, the geotechnical design process played a crucial role in ensuring the stability of the foundations. We start with a comprehensive investigation to assess soil and groundwater conditions. Based on this analysis, we identify different requirements for the 10-story building and the single-story office. This led to the use of deep foundations for the high-rise and shallow foundation for the office to ensuring safety and sustainability while adhering to Euro Code 2 standards. Okay, so for the load distribution, we use mat foundation to spread load evenly. 3 shaft to anchor loads deep into stable soil. Okay, then for the bearing capacity and settlement, we calculate to ensure stability and safety, environmental sustainability. We use minimal excavation and drainage system, and lastly compliance to Euro Code 2 for structural safety and performance. So for the challenges and solutions, for the challenges, we having soil profile challenges. The layered soil with weak layers leading to differential settlement risk. So the solution, we use mat foundation for the single-story management office and reshaft for the 10-story building to anchor the structure. Okay, next is groundwater fluctuations. The seasonal changes near paddy fields, increasing the risk of uplift force and instability. So drainage system to effectively manage groundwater levels and mitigates buoyancy force for the solutions. Okay, next the challenges is bearing capacity issues, the uneven load distribution, leading to potential settlement risk for heavy structures. So the solution, we use mat foundation to ensure effective load distribution, and drill shaft for stable load transfer to the high-rise building. And last challenges is environmental concerns, the potential site disturbance impacting adjacent agriculture, land and habitats. So the solution, we use sustainable construction practices, limiting excavation and implementing erosion control measures.